You are now listening to the Big Data Beard.
Our analytics superheroes assemble!
This episode was recorded at Disney's Data and Analytics Conference 2019 in Orlando, Florida.
Welcome back to another episode of the Big Data Beard podcast. I am Brett, and with me is Corey Benson. Corey, how are you doing today?
I'm wonderful, bro.
Awesome. And we have a very special guest today. I'm really excited about this. We have McKay Curtis, who is a senior principal in the decision science team with Disney. How are you doing today?
Doing well.
Awesome. So do me a favor. Why don't you tell the audience a little bit about yourself and what your role is at Disney?
Sure. So like you mentioned, I'm on the decision science team. I like to think of our team as building the mathematical and algorithmic guts of decision science tools that we then get to give to other units within Disney. So our team ends up doing work for lots of different arms of Disney. Of course, we do a lot of stuff for the parks because we're housed within the parks and resort segment of the company. But then we also do stuff for like Disney Cruise Line or Disney Theatrical Group, which is the Broadway shows. We also do stuff for the Walt Disney Studios. Pretty much any arm of Disney. So ESPN, ABC, we usually have some sort of project going where we're usually doing something like building an analytical tool. And specifically our group focuses on the math behind the tools.
The hard stuff, right?
Well, the fun stuff, in my opinion. Yeah, the fun stuff.
Hard for some of us.
Yeah.
Oh, that's really cool. So when you think of this term decision science, can you unpack that a little bit? Just what does that really mean to Disney?
Well, for us, it's about a lot of our tools have multiple components, but usually there's like a prediction component where we need to predict what's going to happen based on our decisions. And then there's an optimization component where ultimately we want to influence the business to make better decisions. Disney is a great company to work for because the product is incredible. Like I've got great memories going to Disneyland.
Magical, I think.
It is magical. It is magical. So helping a company like that be successful usually means that Disney does more awesome things. Yeah. So, Disney is going to be opened the new Star Wars land in California, and they're going to be opening one, I think, just next week here in Florida. Yeah. We got a free preview as cast members. We got to go see and experience the land, and the ride is incredible. So being on a team that gets to help the business decisions to help make the company successful so that it can continue to do creative, groundbreaking things is really fun.
So your team obviously uses a lot of different techniques to help drive some of these use cases and projects. Can you talk about some of the methods that your teams are using to make Disney so successful?
Yeah, absolutely. So on our team, we usually kind of have two different backgrounds of individuals on our team. We have some people that come in with like an OR/IE background, and they have expertise in some of the traditional optimization methods like linear programming or mixed integer programming. And then we have other people with more of a stats or machine learning background, and they usually build models that produce predictions or estimates of causal effects that then go into the optimization algorithm. So we kind of split the work in that way by hiring people of different backgrounds. And that's usually what goes into each tool that we build.
So what are some of the challenges when you think about trying to deliver decision support systems and automation of those decision support systems with diverse teams like that? What are some of the challenges that you and your team face?
Well, I think one of them is size. I don't think that's unique to us. I'm sure everybody deals with size. So once you get, especially if you think about like the scope of Walt Disney World, if you think about just like the number of resorts and the number of theme parks that we have just here at Walt Disney World, trying to produce tools that will deliver optimal decisions for all of the decisions that have to be made for any given problem, even if it's just simply as like, we want to build a tool for the resorts. Well, depending on how you count the resorts here, we have up to maybe 30 different resorts here, and each resort has potentially like 10 different room types, and they've got different seasons. So I think the scale of problems quickly gets out of hand and is a challenging problem. So especially on the optimization side, there's a lot of smart guys on our team that have optimization backgrounds that are equipped to try and deal with the scope of these problems. And then on the more stats side, I think something that we struggle with a lot is, and I don't think it's unique to us, but it's very difficult to make causal conclusions from data that comes from non-experimental settings. And so that's always like a constant challenge, I think, that we're always aware of.
What do you mean by that? Help me understand. What do you mean, non-experimental settings?
Well, the gold standard for causality is usually running a designed experiment, because you know you've randomly assigned treatment and control, and so background factors, at least on average, shouldn't affect your outcomes. But when you're making decisions in a business environment and you're not allowed to run experiments, then it becomes a challenge because, well, business decisions may have been made because they anticipated a certain outcome.
But that goes to the point that, like, all models are inherently wrong, but many are useful, right? I mean, there's an old saying in terms of like data science, like there's no perfect model.
There is no perfect model, but in an experiment, you don't actually have to rely on a model. What you have to rely on is your knowledge of the fact that things were randomized. And so that can help you. So yes, all models are wrong. The problem is sometimes you don't know how wrong they are.
And quantifying that's hard.
Yeah, and what you end up doing is you end up fitting a lot of different models, and you tweak them, and you look at the results, and you're like, oh, that doesn't make sense, and you socialize them with other people on the team, and they're like, oh yeah, that doesn't make sense. You go back to the drawing board, you fit more models, and at the end of the day, do you really know that the model that you produced is the truth? And many times you don't, and so that's kind of what you get. And so dealing with that, I know there's been a lot of work lately that's been like, I would say advertised, but that's probably the weird, not a weird word. But there's a lot of work in the causal modeling literature lately, like from Judea Pearl and others who take this directed acyclic graph approach, where at least in theory, there's this promise that if you have the right underlying causal directed acyclic graph for your, now I'm getting really mathy here, but causal directed acyclic graph, then yes, in theory, you could estimate the right causal effects. The problem is when we try to implement those in practice, oftentimes when we think, oh yeah, that's the right causal graph, so we should fit that to our data and we should get the right effect. And we do that and we still get results that are a little bit weird, right?
And when you bring that to the business and say just that, how often do they just say, I have no clue?
Yeah,
they glaze over.
I mean, it's a really theoretical issue. So we sometimes the details aren't of the theoretical issues aren't as of all that interesting to our.
But so how do you work with your stakeholders? Like, how is that interaction so that you can translate what you just talked about to something that's meaningful for their outcomes?
Well, I think there's including them in the journey is helpful, because then they generate a healthy understanding of, okay, so this is kind of how statistics works. This is kind of how data science works, and it's not perfect. And so I think they generate a healthy understanding that helps them work better with the tools, because they know when they should be skeptical, and then they maybe get a better idea of when they feel like they can trust the outcome. And I think it's always healthy for everyone, at least until we figure out all these different problems that come up in data science, that to have a certain amount of healthy skepticism with the stuff that comes out of data science and analytical models.
So last year at Disney's Data and Analytics Conference, you gave a talk about reality versus hype of AI. A year later, where do you think we are in that hype cycle? Have we changed anything? Are we still there? And then just where do you think we were last year and this year?
So it actually kind of relates to part of my talk that I gave this year. And I think part of the reason why there's maybe some hype with AI and ML that maybe is not necessarily founded is, like, I don't think that the terminology is clear. And that's been frustrating. And so actually part of my talk this year, I made the argument that there's this notion out there that machine learning is a subset of artificial intelligence. And if you do just a Google search on machine learning versus artificial intelligence, you will see any number of articles that show in a plot that shows like artificial intelligence as the big circle and machine learning as the small circle, and it's contained within artificial intelligence. And I think that's been confusing, because if you look at machine learning textbooks, you will see stuff like linear regression and logistic regression, stuff that was invented in the 1800s before people were thinking about programming computers to be intelligent, right? And they weren't developed for that reason. And so I think if you actually just look at the history of the methods that we call machine learning, it doesn't make sense to call them AI. And yet now everybody's calling everything AI. And I think it's kind of frustrating and has led to maybe confusion, maybe hype. I don't know.
Every model is AI. You build a model, that's AI right there.
Yeah, it's AI because, well, I wanted my computer to do it, and that's what AI is. It's anything I could want my computer to do.
I do a lot of AI.
You still have to teach your computer to do it and update it every day, but it's still AI. It's still.
Yeah, so I argued in my talk that machine learning is not a subset of AI, and we shouldn't think about it that way because it can lead to confusion. And I did my best to cite some experts in the field. There's a paper by Pat Langley called, and he was the original editor of the journal Machine Learning, and it's called "The Changing Science of Machine Learning." And he has some great quotes in there where he was kind of reflecting on how the field has evolved, and that it kind of made this break in maybe the 90s and in the 2000s. It kind of became hyper-focused on prediction problems and kind of broke away from its more traditional AI roots. And so I think it's healthier to think about machine learning as more focused on prediction these days. I know there's a complication that you have reinforcement learning, which in my opinion is more closely related to like optimization methods like that you would find in OR programs like, linear programming or mixed integer programming or dynamic programming. In fact, more close cousins to that. And then there's the rest of machine learning, which is hyper-focused on prediction. And it's not necessarily prediction with the goal of being AI either.
No, it's prediction in terms of we want to find that one metric that can help make those decisions more effective for business outcome.
And I don't even care that they're being done by a computer.
Yeah.
Right.
Just give me a model.
I need the model. I need to make a business decision. And it doesn't matter to me whether it's done on a computer or if you pull it from the sky, as long as it's
I think they call that the cloud, by the way.
The cloud.
You pull it from the cloud.
Do you see as the hype cycle for AI is increasing, more almost, I don't want to say bad practices, but more people just associating AI with everything? And what do you think that's going to do to impact just data science in general?
There's probably going to be burnout, I think, at some point is my guess. I mean, definitely there's many things that were developed in the AI community that were very hard problems that all of a sudden very quickly became what seemed to be easy problems, like the computer vision thing. Last year, my talk focused on ImageNet. I talked a little bit about the history and about how, at what point, where it was. And a lot of my talks are based on like something that I just want to know. I was like, okay, last year was like, where did all this AI stuff come from? Yeah. And so I looked it up and found, there was this ImageNet competition, and it was actually really difficult. And then all of a sudden, one year it wasn't anymore. And then the winning method became the thing to do. And that's now we're all talking about deep learning. And supposedly some of the natural language processing stuff that's happened with that recently has actually happened a little bit before that time. But that was kind of the big moment where all of this stuff took off and really difficult problems in AI became really easy. And then all of a sudden people started using them for reinforcement learning. So that kind of contributed to the hype. But I don't know. I think at some point it'll take some other big moment to push the next big evolution. And I think for right now, maybe, I don't know. Anytime you make a prediction, you end up like this. You kind of end up looking like a dope because it could totally play out
But
wrong.
it gives us something at least to go back and talk about.
A year later,
That's
we'll
true.
either rate this very high
That's
or
true.
very, very low.
Yeah.
I feel like deep learning is becoming the next big buzzword that everyone's just associating. Everything data science is deep learning at this point. And can you talk a little bit about what you think deep learning is and how you define it and kind of how that differs between machine learning and some of the other techniques out there?
Yeah, I just define deep learning as some of these really interesting neural networks that were devised to solve computer vision problems or natural language processing problems that all of a sudden become because people were clever in how they figured out how to fit these models with interesting optimization techniques like Atom Optimizer and then the computing power, and all of a sudden it got really good. Researchers got really good at solving some of these very difficult problems. So that's what I consider deep learning. And if you have a computer vision problem, it's likely that you're using deep learning already because there's really no competitor to it, at least as far as I can tell.
Neural nets are the best.
And there are stuff. So like I said, in our department, we're working on these different problems, and there are problems that we're trying to incubate and see. Okay, what is this new method? Can we do something with this new method? And so things that we're looking at now are, well, let's use some of these fancier neural networks or attention-based networks for some natural language processing problems that we have, and how well are they doing? And they're doing great. They're beating competitors, but they're still not to the point where we could convince a client maybe to use them. And so I think there's some dose of reality there still in that the methods aren't solving everything, at least right now, although they're very good and better than what came before.
Well, yeah, I mean, we're kind of in this, I've heard it called two things. Like there's the post-Moore's Law world where, CPU isn't getting faster, but now there's the Moore's Law of machine learning papers and methods.
Yeah.
They're doubling every month, it seems like.
Yeah.
The other is it's the Cambrian explosion of machine learning is that we're in right now. All buzzwords though, right?
Yeah.
I know you love buzzwords.
Yes, please.
So you did a session this week called the How to Fool Yourself with Statistics in Machine Learning. Tell us a little bit more about what that session, what you were arguing for or against in that session.
So, okay. So that session, actually, it's interesting how talks evolve when you first propose a talk and then it gets accepted and then you actually start doing the research for the talk. It evolves into something that maybe you didn't originally intend. So it kind of evolved into this two talks crammed into one. But the first part of the talk, I wanted to talk about, I actually focused on the first part of my talk about a famous paper from Ed Leamer, who's an economist from UCLA. And he wrote this famous paper called Let's Take the Con Out of Econometrics. And he talked about how in econometrics, and this happens in other areas that use, try to estimate causal effects, is that you end up, like we talked before, fitting many different statistical models, and then you kind of settle on the one that you feel like is appropriate. And he used this really interesting example in his paper of a data set where he tried to estimate what is the deterrent effect of capital punishment. And he had all these variables in his data set that he could include in his model. And he fit different models and basically showed that the deterrent effect, according to the data and the models that you fit, it varies wildly. So which one of those is right? And the answer is we don't know. Now, I know there's been research that's been done since that, and so maybe there's researchers out there who are doing that, maybe argue that they found the right answer. But to me, it looked like the research just ping-pongs back and forth. Oh, there is an effect. Oh, no, there isn't. And nobody has created a consensus because everybody knows that there's this flaw with the modeling in that it just depends on kind of how you decided to model that. So there was that component. And then I also talked a little bit about the replication crisis in science right now. So you could argue that, well, the problem with the capital punishment study was that it was observational data. It didn't come from an experiment. Well, now we're finding that a lot of things that came from experiments are not replicating. So when researchers try to replicate some of these famous results, these results that hit pop psychology textbooks and make a splash in the news, that a lot of them don't end up replicating when researchers try to do an exact replication. And so I talked about that, and just more of a warning of like, you have to have some amount of healthy dose of skepticism for whatever comes out of your models. So that was the first part. And then the second part we kind of already talked about, which was I kind of went into the details of machine learning and how the terminology is used. And I started with this idea that artificial intelligence contains machine learning, and showed that if that's the case, then you end up calling a bunch of stuff that you learned in Stats 101 artificial intelligence, and that doesn't seem like the right thing. And so then
don't rob me of that.
Yeah, sorry to ruin
Everything
your
is AI.
worldview.
Everything
Yes.
is AI.
So so I made my argument that it's not the case. And anyway, I think it was cathartic, certainly for me, but I had people come up and talk to me afterwards, and I felt like it was cathartic for them to hear somebody say that out loud.
So I'm pretty sure we know what it already is. What is the biggest buzzword today in data science?
Yeah, well, the biggest thing is this AI/ML that I see people doing. It's no longer just artificial intelligence. It's no longer machine learning. It's AI/ML, which I don't even know what people really mean.
Well, let's just put so many terms into one term so that we catch everything. So that way we don't get made fun of by other people.
The next buzzword, we will shorten it into 2 letters, and we'll add a slash to it. It'll be AI/ML/whatever.
DL.
Else. Yeah. Yes. DL. Oh, there we go.
/DS for data science.
There we go.
Yep. There we go. OMG. So what's your favorite buzzword out there other than AI/ML? Or most hated? Who knows?
So I don't know if it could be called a buzzword, but my favorite, I think one thing I'm very interested in, because it's such a challenging thing, is causality. And so it's a great time to be studying causality right now, because I feel like there's a lot out there that's exploding in the literature, and a lot of advancements that have happened to help understand how we can and can't get causal conclusions from data that didn't come from an experiment. Like I think I mentioned earlier, a lot of Jatiya Pearl's work. But I also think that has to come with a healthy dose of skepticism as well, too. Even though in theory it supposedly works, it's been difficult to apply in practice. So, but I think that's like a fundamental problem to almost everything that we deal with, is like, we want to know if I do this, what will happen? And that's huge for businesses. And, because it feeds, any optimization you want to do, it kind of presupposes that you know what will happen when you make different decisions. And that's asking about the causal effects.
Yeah. Are you concerned at all about the rampant adoption of AI and model driven activities in so many decision support systems today? Not outside the context of the Disney organization, but just in general in your life as you go through your life. Are you concerned about how people are adopting these technologies without some of that healthy dose of skepticism?
Well, yes and no. I mean, if they are using it where they're actually treating it as if they got something causal, then that's a concern. But a lot of progress can be made just in pure prediction problems. So computer vision is a great example. There's nothing really causal about that. It's just, does this pattern of pixels in an image contain a dog, and I just need to predict that, or a cat or whatever. And so a lot of really cool progress can just be made purely on a raw prediction problem. So some of the things I am concerned, obviously, that's why part of my talk was referencing the out of econometrics paper from Ed Leamer. But good prediction can just be good in and of itself too. So yeah, people can be confused if they treat models that were purely predictive as causal, but there's lots of good stuff that's just purely predictive too.
Yeah. So what do you think is the next year to 2 years look like for data science from a trends?
This is where I get into trouble. I don't really know. Yeah, these things are hard to predict.
And we won't hold you to it, obviously. We'll only make fun of you a little bit a year from now or 2 years from now.
Well, maybe let's spin it this way. What's next for you? Like, what are you thinking about, and what are you wanting to go learn more about as you continue to become you continue your journey as a practicing data scientist and decision support professional?
That's a good question. I would like to study more. It's actually kind of funny because as a statistician, so in statistics departments, you can get into very like traditional statistics department that like came out of agricultural departments, where it's like, we're going to design a field experiment, and here's your plots of land, and we're going to divide it up this way. And they talk about experimental design. And for me, I hated those classes in school. I thought design of experiments was incredibly boring. But I ended up having to take a lot of them because I went to kind of some ag schools. And now I've kind of come full circle. I'm less confident that I can get lots of good information from just modeling things that didn't come from an experiment. And so now I've kind of come full circle. I'm now very passionately interested in design of experiments. And how do we design experiments in very difficult cases where it's very hard to design an experiment. And we actually had a speaker here at the conference this year, Ido Airoldi from Temple University, who talked about designing experiments when the treatment that you assign to one individual could impact the effects on a neighboring individual. And he's proposed some interesting things that I hope to investigate further.
We've learned a lot from our guests about big data, but now it's time to get a bit personal in a segment we like to call Rapid Fire. Pew, pew.
What is the latest book that you've read that you would recommend to our listeners?
I've only been able to read things related to my talk over the last few months, so it's going to be one from my talk. But basically, I would say Uncontrolled. I think Jim Manzi is the author, but again, he's talking about experiments.
Yeah.
Okay.
And I like he's come up with some interesting terminology, like causally dense is one of the terms that he came up that I think is impactful.
That's a deep word, man.
Yeah,
I dig that.
It sounds deep.
So you had a chance to talk at the conference, but if you had a chance to pick a song that was playing as you walked on stage, what would that song be?
There is a song off of a Stone Roses album, and I don't think the song was very popular, but there's a point in that song where it starts out. The song's called Breaking. I think it's called Breaking into Heaven. Okay. It starts out with like 4 minutes of just like jungle sounds and maybe these kind of just subtle drum beats, and then all of a sudden, out of this chaos evolves this like deep, funky guitar. It's super awesome. It's like right about the 4 minute mark. But
all right,
That's the point I would want to walk out on
At
stage.
that point,
Yeah,
I was going to say
right
4
at that
minutes is a
point.
long walk.
Well, as they say, 4 minutes, it's like everybody getting seated. They're like, what are these sounds?
Yeah, exactly.
Where
like
are we
that.
right now?
Yeah,
That's awesome.
But it is really it is groovy. Yeah.
Dig it.
Groovy. I like it. So what is your biggest personal money pit right now?
4 children.
Yeah, that's that
4
matters.
children.
Yeah.
So is there a piece of technology that's making your life worse today?
Well, kind of going back to the money pit, I'm a sucker for textbooks. I end up spending an inordinate amount of textbooks of money on textbooks, and so I don't know. And the fact that I can buy a textbook and put it on a Kindle version or something like that just means that I don't have to worry about storing the textbook. So it's less of a cost because I don't have to worry about storing it. So I don't know, maybe e-readers is a piece of technology because then I just spend more on textbooks.
Are there any shows that you're binging on right now?
Well, not very many because I've spent most of my time trying to research for my talk, but I did binge a while on some HBO documentaries. So there's some really interesting, like true crime ones. There was like, I Love You Now Die. I know these are kind of morbid, but it's like, and then there was another one like Who Killed Garrett Phillips. And then there was like Jihadi John. And then totally different than those is a Muhammad Ali documentary, which I thought was awesome.
That's awesome, man.
Yeah.
So in your professional life or personal life, are you going anywhere interesting soon?
We're doing a staycation. Like in a week, we're going to stay at the beach club here on property, and they have one of the best pools on campus.
Really? Okay.
Yeah. They got a nice lazy river, and they've got a sand bottom portion of the pool.
That's awesome.
It's awesome.
With 4 kids, that's awesome. Staycation.
Yes.
Totally understand that. Well, McKay, it's been awesome to have you on the Big Data Beard podcast, and thanks for hosting us at Disney's Data Analytics Conference 2019.
No problem. Great to be here.
Cheers.
Thanks.
Thanks for listening to the Big Data Beard podcast.
The music from this episode is by Andrew Belle. Check him out on iTunes or Spotify.
And be sure to smash that thumbs up button so we can keep the episodes coming. Until next time, keep being awesome.